Hello everyone, myself Dr. M.S. Meena, PGT Chemistry from Kendriya Vidyalaya, Mathura Refinery Nagar. Today we are going to discuss about unit number 3 of chemistry, that is electrochemistry. In this unit we will divide it into two parts. First part considered till Nernst equation, and the second part starting from batteries to till end. So in this video we will discuss first part of electrochemistry. The unit number 3, electrochemistry, of class 12th chemistry. Electrochemistry deals with the chemical reactions that produce electricity and the changes associated with the passage of the electrical current through matter. The reactions involve electron transfer, and so they are oxidation reduction or maybe a redox reaction. Many metals may be purified or electroplated using electrochemical methods. Devices such as automobiles, smartphones, electronic tablets, watch, pacemakers, and many others use batteries for power. Batteries use chemical reactions that produce electricity spontaneously and that can be converted into useful work. All electrochemical systems involve the transfer of electrons in a reacting system. In many systems, the reactions occurs in a region known as the cell, a particular device which is known as the cell, where the transfer of electrons occurs at electrodes. So now we will move on next slide, electrolysis. Electrolysis is the process in which electrical energy is used to convert or to drive a non-spontaneous chemical reaction. Do you know non-spontaneous chemical reaction? Okay, non-spontaneous reactions means the reactions in which a use of a catalyst or the energy to lower the energy requirement to take place. That is, they can only occur if energy is put into the reaction from an external source. Then, an electrolytic cell is an apparatus for carrying out electrolysis. Processes in an electrolytic cell are the reverse of those in a galvanic cell. Electrolysis of water requires an electrolyte species that is less easily oxidized and reduced than water to carry the current. As we know that electrolysis of water can take place into anode and cathode reactions. Anode, water is oxidized to oxygen gas at anode. As per the electrochemical series, water molecule oxidized or loss of 4 electron convert into oxygen molecule with the help of 4H plus ions. And at cathode, water is reduced to hydrogen gas. As we know that water molecule gain of 4 electrons to give 2 molecules of hydrogen gas and 4 hydroxide ions. Electrolysis on over voltage. Over voltage, additional voltage needed to maintain the rate of electron transfer at the electrode solution interface. But what do you mean by over voltage? Over voltage, when the voltage in a circuit or part of it is raised above its upper design limit. This is known as over voltage. Overvoltage is required when a half reaction has a significant activation energy and so a slow rate. Overvoltage for formation of O2 or H2 is much greater than the formation of chlorine. Quantitative electrolysis. Before understanding the quantitative electrolysis, we have to understand the Faraday's laws of electrolysis. Faraday's laws of electrolysis, we must first understand the process of electrolysis of a metal sulfate. Whenever an electrolyte like metal sulfate is diluted in water, its molecule split into positive and negative ions. The positive ions, it may be metal ions, move to the electrodes connected with the negative terminal of the battery, where these positive ions take electron from it, becoming a pure metal atom and getting deposited on the electrode. The negative ions or sulfate ions move to the electrode connected with the positive terminal of the battery, where these negative ions give their extra electrons and become sulfate radical. Since sulfate cannot exist in an electrically neutral state, it will attack the metallic positive electrodes, forming a metallic sulfate, which will again dissolve in water. So, the quantitative electrolysis, the amount of substance produced at an electrode by electrolysis, depends on the quantity of charge passed through the cell. Hence, here one more important topic is Faraday's law. Faraday's first law say that the chemical deposition due to the flow of current through an electrolyte is directly proportional to the quantity of electricity in coulombs. It means directly proportional to the quantity of electricity passed through it. And the Faraday's second law of electrolysis states that when the same quantity of electricity is passed through several electrolytes, the mass of the substance deposited are directly proportional to their respective chemical equivalent or equivalent weight. So, reduction of 1 mole of sodium ions requires 1 mole of electrons to pass through the system. The charge on 1 mole of electron is 96,500 coulomb. 96,500 coulombs, it is a 1 unit of 1 F. 1 F means 1 Faraday. Commonly, it is called Faraday's constant. The exact value of Faraday's constant is 96,487 coulomb. But it is, for calculation purpose, it can be considered as 96,500 approx in coulombs. Now, to determine the moles of electrons passed, we measure the current and time that the current flows. Charge is a multiplication of current and time. Current can be measured in ampere and time in second. Then charge C is equal to current into time. Because the charge on 1 mole of electron is 96,500 coulomb, the number of moles of electron passed through the cell is given by the following expression. Moles of electrons is equal to charge into 1 mole of electron upon 1 Faraday. Redox reactions. Redox reactions are those reactions in which reduction and oxidation will take place simultaneously. In redox reactions, we can understand the cell. For redox reactions, a cell consists of two half cell reactions. One is oxidation half reaction and another one is reduction half cell reaction. Oxidation half reaction, here we can take the example of zinc and copper. When we place zinc strip into copper sulfate solution, the color of copper sulfate solution is blue, and the zinc strip, color of zinc strip is silver. Zinc strip is placed in a copper sulfate solution. Copper sulfate solution here acts as an electrolyte. Zinc loses its 2 electrons to give zinc ion Zn2+, and in this solution freely copper ions are freely moved. They can get 2 electrons and converted into copper solid. We can see it in next slide. Here, reduction half reaction, copper ion Cu2+ ion get 2 electrons. These 2 electrons come from zinc metal. Copper ions, after getting the 2 electrons, converted into copper solid, and the copper is deposited on the outer surface of the copper strip. The copper 2+ ions gains 2 electrons to form a solid copper. In this case, zinc strip reduce its weight and copper strip gain its weight. These two half reaction cells are connected by a metallic wire, or along with this by a salt bridge. A salt bridge in electrochemistry is a laboratory device used to connect the oxidation and reduction half cells of a galvanic cell. A type of electrochemical cell, it maintains electrical neutrality within the internal circuit, preventing the cell from rapidly running its reaction to equilibrium. So, salt bridge is an important device. The function of salt bridge is many times asked in CBSE examination. For example, what is the function of salt bridge, or what are the main functions of salt bridge? So, the salt bridge maintains the electrical neutrality and to complete the circuit of two half cells, reduction half cells and oxidation half cells. Overall cell reaction for zinc and copper. Zn in solid form, it lost 2 electrons and converted into Zn2+, and these 2 electrons goes into the electrolyte of copper sulfate, and copper ions Cu2 plus ions get 2 electrons to convert into copper solid. Hence, this is the overall redox reaction. Now, electrochemical cells. First of all, we are going to discuss some technical keywords. Electrodes. Electrodes are usually metal strips, wires connected by an electrically conducting wire. And salt bridge, as we know that salt bridge, we have already discussed it, is a U-shaped tube that contains a gel permeated with a solution of an inert electrolyte and KCl, potassium chloride. KCl is provided in KCl. Why we use KCl in salt bridge? Because KCl is provides us to K plus positive ions and chloride minus ions, Cl minus ions. Next, anode. Anode is the electrode where oxidation takes place, and it is placed at left hand side of the cell. Cathode. Cathode is the electrode where reduction takes place, and as per the IUPAC convention, it is placed at right hand side the cell. Convention for expressing the cell. It is very important. Anode, half cell, and cathode, half cell. As we know that complete cell reaction can be divided into two half cell reactions. First, anodic reaction and cathodic reaction. Anode half cell reaction and cathode half cell reaction can be distinguished by two vertical lines between anode and cathode half cells. Anode half cell is made up of electrode and anodic solution, and cathode half cell is made up of cathodic solution and electrode. So we can easily write the expression of the cell, electrochemical cell. We can represent electrode is zinc solid, single vertical line, then anodic solution zinc 2 plus, then double vertical line, cathodic solution is Cu2 plus, then single vertical line, electrode copper. It means that first we can move from left to right hand side. Left hand side is anode and right hand side is cathode. As left hand side zinc electrode, first we can write zinc strip as solid, then first vertical line. After that zinc strip is placed in zinc sulfate solution. So after first vertical line Zn 2 plus, we can say that. Then this is the half anodic cell reaction. Then two half cell reactions can be distinguished by two vertical lines. Now we can come on the topic of electrochemical cells. Standard potential of any galvanic cell is the sum of the standard half cell potentials for the oxidation and reduction half cells. It means that E naught cell is equals to E oxidation plus E reduction in its standard form. Standard half cell potentials are always quoted as a reduction process. The sign must be changed for the oxidation process. So the standard half cell potential are determined from the difference between two electrodes. Now here is some important terms for electrochemical cells. Number one is electrode potential. Electrode potential. What is the definition of electrode potential? Electrode potential is the potential difference between an electrode and electrolyte is called electrode potential. Once again, the potential difference between an electrode and electrolyte is called potential difference. And cell potential? The cell potential is the potential difference between two half cells. The cell potential or potential difference between two half cells is called cell potential. And standard cell potential, the potential difference between two half cell reactions or two half cells at it in standard conditions is called standard cell potential. Now the reference point is called the standard hydrogen electrode SHE and consists of a platinum electrode in contact with hydrogen gas. Hydrogen gas is filled in 1 atmosphere and aqueous H plus ions, 1 molar of its concentration. The SHE is assigned an arbitrary value of exactly 0.0 volt on the basis of electrochemical series. Electrochemical cells, this is the important electrochemical representation of electrochemical cell. Here zinc plate acts as an anode which is negatively charged. Zinc strip dipped in copper sulfate solution or copper nitrate solution. Here these two half cells are interconnected with a salt bridge. Salt bridge is a U-shaped tube of potassium nitrate, sodium chloride or potassium chloride and agar-agar powder. Here anode oxidation will take place at anode and reduction will take place at cathode. Here cathode is SHE, standard hydrogen electrode. With the help of this electrochemical cell, we can measure